Hello everyone. Today we are here to learn chapter factorization, which is chapter number 14 in NCERT book of grade 8. So before we start this chapter factorization, first of all I would like to tell you what are factors. So factors means we just split the number, okay, into its factors. We have already learned in the chapter factors. So if I take the example of natural number, that is 15, I can write its factors as 1, because 1 is the factor of every number. So I can write 15 as 1 times 15. I can write 15 as 3 times 5, right? So if I sum up the factors of 15, I can write the factors as 1, 3, 5 and 15. Okay, so these are the factors of natural number 15. Now here we need to learn factors of algebraic expressions also. So let's take example like 2xy. Now in 2xy, it has a factors like 2, then x and then y, right? And as we all know that 1 is a factor of every number, so without fail 1 is a factor of 2xy also. If I take algebraic expressions like 10xy, so I have to split first 10, that is I can write 10 as 2 times 5. So 2 times 5 times x times y times 1. So these are the factors of algebraic expression 10xy. Now if I take some algebraic expression like 7x, and in bracket I have x plus 5. Okay, so let me tell you, factors can be separated only when they are in multiplication, not when they are in addition. Okay, so x plus y, we cannot take separate factors as x and 5, because x plus 5 is a factor itself. So its factors are 7x factor are 7 and x plus 5 is a complete factor. Okay, so for this algebraic expression, you can see 7x and x plus 5 are its factors. Let's see now what are factorization. So basically, when we factorize any algebraic expression, we write it as a product of its factors. Okay, and these factors can be anything. If we are talking about natural numbers, then natural numbers. If we are factorizing algebraic expression, then different algebraic terms are their factors. Now let's see different methods of factorization. And so first factorization method is common factor. Common factor. So by this method, I can say, for example, if I have 5xy plus 10x. Okay, so we need to factorize this algebraic expression. So let me split first its factors. So the factors of 5xy are 5x and y. Same manner, 10x has a factor of x first of all, and then 10 has 2 and 5, right? So these are the factors. Now let's see what is common in between them, because our factorization method's name is common factor. So we need to find the common factors. Let's see which are the common. I can see 5 here, 5 here. I can see x here and x here. So we got our common factor. So I can write 5x separately. Now what's remaining with 5xy after 5x is removed, or after 5x is taken common? Yes, y is remaining. And let's move towards the 10x term. In 10x, if we took common 5 and x, what is remaining? 2. Okay, so in this way we have factorized our algebraic expression. So now we have 5x in bracket y plus 2. This is our factorization method by a common factor method. Now let's see the second method. Okay, Second method of factorization is regrouping terms. Regrouping terms. Now, if I take example for regrouping, first of all, I have two examples for this to tell you how you need to regroup. So name itself indicates we need to regroup, already they are in a group, and we need to arrange them in different groups. Okay, so our example is 2xy plus 2y plus 3x plus 3. Okay, so now regrouping, we need to regroup them. If I say which are the common factors in whole this expression, we do not find anything common except one. Okay, so that is why if we do not find anything common between whole expression, let's just group them in like two twos. Can you find what is common in these two? 2xy plus 2y. So yes, exactly, we have common 2y. Now what is remaining if 2y is taken common? So you can see 2 is gone, y is gone, only x is remaining, and here 2y completely gone, so only 1 is remaining, right? Then plus sign as it is. Now what is common in this terms? So yes, we have 3 in common, and then 3 is taken in a common, so removed, what is remaining? X plus 1. Yes, this is what we need, students. When we are grouping them, we need to have the same factors in a bracket. So we got them, and yes, so if I write my common factor, that is x plus 1, what is remaining outside the bracket? That is 2y plus 3, and done. This is our factorization done. We factorize this expression. Now what if I just if you have right now, you can say that okay, this expression has this 2 here, 2 here, so we got easily something common. Now let me arrange them in such a manner that we do not find easily something common. So let me take it like 2 x, while keep as it is, plus 3x plus 2y plus 3. You can see I have separated them on the basis of what we found them like some common factors, right? So now again, we have nothing in common in whole expression, so we need to look for common in these two expressions, right? So what we have common here in 2xy plus 3x, we have x, correct? So we have x common, then what is remaining? X is gone from this side, x is gone from this side. So what is remaining? It's 2y plus 3, right? Plus sign as it is. Now what is common in 2y plus 3? There is actually nothing common. And you know, factor of every number 1 is already there. So if we have nothing in common, we can just write 1 as a common and then 2y plus 3 as it is, because nothing else we took as a common. So let me write my common factor, that is 2y plus 3, and what is remaining outside the bracket, that is x plus 1. So can you see, I just rearranged the expressions and I got the same answer at both the places. So this was our second method. Let's move towards the third topic, that is third method of factorization. And the third method of factorization is using identities. Now you must have learned what are identities. So third method is by identities. Right, now which are the identities? Like for example, we have identities a plus b whole square. So it will be, so these are, you also can say you have you must have done formulas, a square plus twice ab plus b square, and in a minus, a minus b whole square is just the difference is the middle minus sign, rest everything is same. So this is one identity. Then third identity you must have learned, that is a plus b and a minus b. What is its factorization? That is a square minus b square. Then we have fourth identity, that is x plus a and x plus b. So if you solve it, you will get x square plus a plus b in bracket x plus ab. Yes. Okay. Now these are the identities. You can say these are the formulas. Let's see how can we factorize with the help of these identities. Now if I take example, that is, which is already there in the NCERT book, that is x square plus 8x plus 16. Now let me tell you how to identify that this expression belongs to the identities. You can see that you have x square, which is already there in identities. You have 16, which is the square of 4, which is also a part of identity. And as you can see, both the places there is a plus sign. So yes, we can use this first identity, that is a plus b square. Okay, so let's separate this. The only problem here is a middle portion, that is, in our identity we need twice ab, and here we have 8x. So let's convert it first. X square will be as it is, and we are just changing the middle term. Okay, so middle term, if we are changing to make it to fit it into our identity, I can write like 2 times 4 times x to the 8x. Can I? And then 16, I can write it like 4 square. So now can you see, I have converted into our identity pattern, x square plus 2 into 4 into x plus 4 square. So now it's in our format. Now we have got our a and we have got our b. So let's write them into our identity, that is our a is x, right? So x plus, what is our b? 4. X plus 4 whole square. So our factors are x plus 4, because it's whole square, so x plus 4 and x plus 4. Yes, so this is, and the same thing goes if you have something over here which has a negative sign, so you should use our identity, that is a minus b whole square, right? Now let's see the third method of factorization. Okay, so third method is, you can see that example which I gave, that had 16 as a b. Okay, that was 4 square. So many times you get expressions which has the last number which is not square, and you can see there is only one identity which doesn't end with b square. Okay, so when we have expressions which doesn't end with square, how to deal with them? Okay, with this our last identity, x plus a, x plus b. So if I take example again, like um, x square plus 5x plus 6. Okay, so you can see we don't have a square number over here. It is 6. It is not a square of any number. So basically, yes, then it belongs to our fourth identity. And to make that, you can see here we have a plus b, right? So we need to change here our x square we already have, and then 6, I will tell you what has to be done, but we need to convert it into a plus b to this middle term. Okay, so now we are adjusting just the middle term here. We are going to make the changes only in middle term. The first term will be as it is, that is x square, and the last term 6 will be as it is. Now how to change the middle term? There are rules how to change the middle term. So basically, middle term should be factorized in such a manner that whatever, suppose a and b factors you have, so those a times b must be this 6. Got it? Not only 6, actually, we always say that whatever the coefficient here, right now it's 1, so 1 times 6. 1 times 6 should be equal to a plus b. Sorry, I wrote here multiplication, a plus b. Okay, so right now we have here 6 times 1, 6. Okay, so we need to find factors of 5x in such a manner that we need to get, by adding those factors, we should get 5x. If you do not understand, let me just tell you with example. So let's find the factors of 6 first. So 6 can also be written as 6 times 1. 6 can also be written as 2 times 3, right? So you can see here we have got factors 2 and 3. So this is what I was saying, that factors of 6 in such a manner that if you add them you should get this middle term. So here we have 2 plus 3 will give us 5x. Yes, we got our middle term factors. Okay. So now I can regroup it, or I can write it like x square as it is, and I can write my 5x as 3x plus 2x plus 6. Now did you understand? We took multiplication of coefficient of the first term and the last term, and then whatever 6 has come we took its factors, and factors also we should choose in such a manner that when you add the factors you should get the middle term, that is 5x. If it is still confusing, I will take one more example to prove this, but let's just complete it. So we have separated, or we got the factors of this expression. Now let's see what's common over here, x square and 3x. So yes, we have common x. If I take x common, okay, we have x square, so if I take 1x common, I have 1x with me, and plus 3 as it is. What is common here? 2x plus 6. In 2x plus 6, we have 2 common. So what is remaining? X plus 3, because 2 times 3 is 6. So can you see our brackets are same? This is what we need. So I have factors like x plus 3 and x plus 2. Right? So this is our factorization. Now let me tell you, let me take one more example, because this is very important method. Not many equations will have square at its end. So let's see one more example. If I take example like 3x square minus 11x plus 6. Right? So as I was telling you, we should multiply coefficient of first term and last constant. Okay, so if we multiply, now if we multiply 3 times 6, we get factors, we get 18, right? So you need to choose factors of 18 in such a manner that by adding them you should get 11x. So 18 factors, let's see, 1 times 18, but it doesn't match with, we cannot add 1 and 18 and get 11. So yes, let's see the another factor. Another factor of 18 is, I can write 9 times 2, I can write 6 times 3, right? Now let's see by adding which numbers we get 11. 6 plus 3, 9, not 11. So not interested. And 9 times 2 is 18, and 9 plus 2 is also 11. So yes, we got our factors, that is 9 times 2. Now let's solve it. Okay, so I'll write the 3 square as it is, 3x square as it is. I'll write 11 because minus sign is there, and our factors are 9x plus 2x, and minus sign is there, that's why I have to write like minus 9x minus 2x, because minus minus makes it plus. So minus 9x minus 2x makes it minus 11x, and 6 as it is. Now let's see what's common here. In 3x square and 9x, we have common 3x, right? So now after taking common 3x square, so 3x square, we got 1x out, 1x is still there, minus, if we have 3x common, we have just got x minus 3. Now minus sign as it is, what is common in here? 2x plus 6, we have 2 common, right? And then after taking 2 common, we have x remaining there, and sign will change because there is a negative sign uh, outside the bracket. So minus After taking 2 common, we have 3 remaining. And now our first factor, that is x minus 3, and our second factor is 3x minus 2. So you can see this is the way, with the help of identities we can find the factors. We can do factorization. Okay, students, so these were the factorization techniques, factorization methods. By these methods we can factorize the expression. And now let's move towards the next topic. So everyone, this was the part 1 of chapter factorization. Factorization part 2 will be right in the description of this video. Please find the link of this part 2 in the description below. Until then, see you. Bye bye. See you with a new topic. Bye bye.